In this video I have one example dealing with inscribed angles and calculating the measures of two different angles, actually four different angles. I didn't put it in my directions, and sorry about that, but in this problem what I ultimately want to do is I want to find the measure of the four red angles. Measure of angle 1, the measure of angle 2, the measure of angle 3, and the measure of angle 4. Now what I'm going to do is I'm going to mark up my picture. And I'm going to start with this piece right here. It tells me that arc VU and arc SU are congruent. Well, here's arc VU. Maybe. Oops, let me undo that. Try this again. So we have arc VU and arc SU. So I know these two arcs are congruent. I'm going to mark that. And the other thing I know is I know the measure of angle 2 down here. This one is x plus 9 degrees. And then the measure of angle 4 is 2x plus 6. And you say, well, where do we go from here? Well, what I'm going to start with is I'm going to start with that blue stuff. It told me that those two arcs were congruent. Well, I'm going to find then the inscribed angles. Or, yes, the inscribed angles that essentially make those two arcs. So from V, I can follow that down. I didn't want to use this color. Let me try a different color. Let's go with purple. So I'm going to go from V, I can go down this way, and then from U, I can come down this way. So I know that angle 1 is the inscribed angle, and arc VU is the intercepted arc. I'm also going to look at then the other part of my blue statement that says arc SU is congruent to that, and I'm going to look for an intercepted arc, or an inscribed angle from there. So from S, I can follow that down to point T, and from U, I can follow that down here. Now, what I see there is I have angle 1 and angle 2 are angles that have congruent intercepted arcs, which from the theorem that we just learned about in the lesson portion, those two angles are going to be congruent. So angle 1 is going to be congruent to angle 2. If I could find the measure of angle 1, well, I know the measure of angle 2 as well, and vice versa. So there's one start. Now, another thing that I want to look at is the fact that I'm going to go like this. It tells me over here that I'm working with circle P. Therefore, P is the center of the circle, and then segment UT has to be a diameter. Well, if that's a diameter, then this right here has to be a semicircle, and then that means that this arc here is also a semicircle. So I know the measures of those two arcs is going to be 180 degrees. And what I'm going to do from there then is I'm actually going to go like this and eliminate this one for the time being. I don't want it right now. I'm going to take this arc, it'd be arc TVU, and I'm going to find the inscribed angle that created it. So what I can do is from T, I can follow that back to S, and from U, I can follow that back to S. Remember, since this arc is 180 degrees, its inscribed angle is going to have to be half of that. Therefore, this angle here at S, call it angle UST, is going to have to be a 90-degree angle. Which really, I can stop right now. I have all the information I need, because what I'm going to do now is I'm going to look at the triangle that I see inside of this circle. I know it's a right triangle. I have the measures of the other two angles in it. In terms of x, I can write an equation to solve this equation. So I can take the measure of angle 2, which is x plus 9. I'm going to take the measure of angle 4, which is 2x plus 6. If I add those together, and also add on the 90 degrees for my right angle, oops, I know this is all going to equal 180 degrees. Now I have an equation that I can solve. I'm going to go ahead from the get-go, and I'm going to subtract 105, because that's the 9 plus 6 plus 90 from both sides. And now I have 3x equal to 75. Divide both sides by 3, and I find out that x equals 25. Come back up here. I can start plugging that in. So the measure of angle, I'm going to start with the measure of angle 2. Well, that's the 25 that I just got from my x value. Add on the 9, and I find, oops, forgot my 2 in here for the measure of angle 2. I find out that the measure of angle 2 is equal to 34 degrees. Now remember, we said the measure of angle 1 was congruent to it, so it's going to have an equal measure. I now have the measure of angle 1 and the measure of angle 2. I could then go up to and work on the measure of angle 4. So the measure of angle 4 is equal to 2 times our x value, which was 25. And then we have to add on 6. So that puts me at 50 plus 6. I end up with the measure of angle 4 equal to 56 degrees. That's an equal sign. Which should make sense because 34 plus 56 plus 90 puts you at 180 degrees. Now the only thing that we're missing is the measure of angle 3. Well, you can go back to what I had talked about earlier. I had drawn this in once already, that this arc here, or this semicircle, is 180 degrees, which then if I follow that back to the inscribed angle that creates it, that would be angle V. That's a 90-degree angle. And then if angle 1 and angle 2 are congruent, angle V and angle S are congruent, well, using the third angle theorem, that's going to tell us that angle 3 and angle 4 have to be congruent. Therefore, the measure of angle 3 is also going to be 56 degrees. So I found the measure of all 4 of my angles, and I used a lot of theorems that we've talked about either in this lesson on inscribed angles or some previous lessons as well. And that's going to conclude my example dealing with the inscribed angles.